So this is team ID 2160 for the first run. So we load their Python output that they were able to detect. So over here also, out of 60, 55 instruments were correctly identified, 52 nodes were correctly detected, and there is only one node where the onset was little late. So now the team will perform their this run on their laptop, right? So I will just switch their.
So we'll be performing the demo in our laptop because prior to the event, our system was not working in the laptop. There was some error, but it was working in our laptop. So we go ahead with our laptop. So let's.
Yes, sir. Yes, sir. But the sound will not come.
No, that's okay, but is that fair to the other teams?
The ping instrument, they are playing with their serial communication. But it is this is also given by us, and it will generate the entire data, instrument, note, and the onsets. But they have only the PyC file of that.
No. We should have equal playing ground for all teams.
Actually, they haven't followed the format which we have given.
Then I mean, because let us know, I don't know what you feel. Let us not have different evaluation methods.
They ask you want them to be considered for the competition.
You have to play by the competitions.
Like the other teams.
So initially, this team required the Python file to give three arrays, instruments, onsets, and nodes, and that had to be communicated to the bot through serial communication. So prior to the event, it was said that the serial communication part will not be taken place, but we wanted it to do because we had written a code for that. So we requested the team, and they agreed to that, and we are using a serial communication. There is nothing different. It's just that it was already there in the theme, and we are just implementing that, and it's easier for us to do that.
Actually, many could not do this part, so it had been removed from the competition.
Team owner should clarify this. Why you decided to give them this exception?
So, yeah, actually, yesterday this thing is working with our GUI, and we have tested it, and today morning when we tested, it wasn't working.
But
so
then the last team also argued that it was working, and right. So how can we change the rules for one team?
Okay, so we can do one thing. We'll use the same ping instrument.py which we have in our laptop, and they'll communicate to that ping instrument. Only the note will not be played, the GUI will not be seen, but they will be communicating to our laptop only and our code only.
And
So
the
is that
evaluation,
fair?
sort of automated evaluation rules are the same then as the other teams?
Yes. So what it will do, it will print all the instruments, notes, and the onsets on the terminal. So we'll copy paste into our GUI as a separate arrays, and we'll comment the serial communication part, and the remaining GUI will work as it is.
But as far as judging is concerned, would that happen right now, or that is post-processing that you will do later?
So we have to copy paste, and then we have to
How much?
arrange it into the array. So
How
it
much
will
time?
take 10 to 15 minutes. If it is okay, we can show that GUI part also.
It is fine.
Yeah?
Let us try to keep the rules same. So then play it on your laptop.
Yeah. It
And
will
then
be
post-process the score later if you need.
okay.
Yeah.
Fine. Is that
Right?
fine with the others?
Yeah, you see,
Yeah.
and there should not be any complaints later on from other teams also. You have to be careful.
So we'll ask upfront only.
You can maybe have any comments about.
So we can have one thing, as they haven't followed the format. We can have some penalty points. Okay.
No, but I thought before your second attempt, did you not say that we can show which instrument that? But we don't know that is allowed. No, I thought you said that you will show and we said okay. And then you didn't do it. They are not allowed. Well, gentlemen, you just said before your second attempt that you would use the instrument.py. They said okay, we said okay, and you then executed it again. That is exactly what happened.
So what they have to say?
You did not allow this
To run the ping instrument.
Yeah, but it will be the same. It is on our.
The delay won't be there. We are sure.
So we see if it is working with the GUI. If it is works with the GUI, we'll stick to that only.
I would also
Yeah.
prefer that.
Yeah.
Let us keep the rules the same for all.
Yeah. We'll check for 5 minutes.
Switch the screen.
It's working with the GUI. Yeah, so we'll stick to the GUI part only. They said it. Yeah, they said start from So it's working with the GUI. So we'll stick to the GUI part only. So it will be fair for some. On our laptop only, the previous GUI which we have tested for other teams.
So this is team ID 2160 taking their first run. So this is their Python output. So out of the 65, they are able to correctly identify 55 instruments, 52 nodes, and just one node with the onset error. So on the count of 3, okay? 1, 2, 3, go.
In this mechanism, we are demonstrating which key is pressed. So whichever key is to be pressed, light will blink. Okay. So will be visible for all the audience also.
So the serial, yeah, at 73. So the serial communication is stopped. So let's see what they had actually played. The notes that were played were incorrect. So that's why the sound of the original wave file is not as that. And the team has also just won this. So that's why there will be one penalty. Scorers, please note this. So do you want to do second round? So the total time that we can see over here is 73 seconds. I mean, the actual audio file was 50 seconds and there was just 23-second extra delay. serial communication किया? 2160 is taking the second run. We hope that this time they play the actual wave file. NCD parameter will remain the constant. Ready? On the count of 3. 1, 2, 3, go. So the bot has already said that it is end of run, but with the lag in the serial communication, it is playing the previously played notes on the UI.
So as you can see, to indicate the press of a key, we have put blue LED lights so that it's visually indicated that a key has been pressed. And now it's the end of the run.
Notice, please note the values for the second run. Noted? Okay, noted.
So these were the 5 themes we have completed with the Mockingbird theme.
Oh, that's you. Can you introduce yourself, year and department?
Up to you guys.
Your name, year and department.
So my name is Piyush Goenka. I am in third year Electronics and Communication Engineering.
My name is Nikhil Bhat. I'm in third year EC department.
Myself, Ankit Kumar, ISC department, Information Science, third year.
Ramanath Amith from third year EC.
So you want to say who did what part of the project?
So my name is Nikhil Bhat. So I did the ML part and the onset detection part.
My name is Piyush Goenka. I did the embedded systems part.
My name is Ankit Kumar. I did mechanism part and coding. I helped them in coding also.
My name is Amit. I did node detection and a bit of onset detection.
And how did you hurt yourself?
I was going in steps. I fell down.
Not related to the project.
Like
Yeah,
wanted to go bring some instruments.
No, not here. Bangalore itself. So as far as mechanism is concerned, we have tried to keep it simplistic and fastest as possible. So we have a response time of like 200 milliseconds in between. So any gap in between like 200 milliseconds will be cached and played. And the reason for choosing solenoids was pretty easier to control, as giving a signal only as true or false, 0 and 1 will activate it. And for accuracy, we did the laser cutting thing.
There is a lot of repetition in your design.
Yeah. So we have created a prototype of single module and repeated it for each and every stacking module.
So in CAD we had designed for one module and we repeated for 8 times. 8 keys. And we went to the laser cutting shop and
So for training, again machine learning question. So which technique you have used?
Our technique is like pretty unique in the sense that we have used three different models. So the first model we have grouped together piano and trumpet and violin flute. So we have done a binary classification on those both. And then if it's detected as piano or trumpet, we have done a Adabush classifier which classifies between piano and trumpet. So three different classifiers we used so that initially we tried SVM on all four and related to the research paper with C and gamma values, but we are getting horrible results. So we thought let's switch over and do something new, and we did this method.
Yeah.
So we are getting good results with this, so we stuck to this.
Absolutely. Have you tried XGBoost? Have you considered it?
Which one?
XGBoost.
XGBoost? No, we have not considered that.
So apart from that, which you have thought about which can work?
Actually, we have tried like all the classifiers in the book. First, we had done MLP, and we have went with recurrent neural networks as well. But then our TensorFlow was based on Python 3, so we had to, and we had asked the question, could we use Python 3? So we had to ditch that plan and we had to come up with a new plan for this classifier. So we did this. So a lot of classifiers we had to train.
Yeah.
So this.
Okay. All the best.
Hey, so I actually like that you have this rigid construction, right? But I think on the keys it was not rigid, so you saw the key moved. Yeah, so never stick, always use nuts and bolts. Why did you make such a tall and such long things? It could have been more compact.
We had to place all motor drivers for solenoids and the rivets, and in between the spacing is needed for lever action also. So considering we created some 5 models with different heights and dimensions, and this was the best thing which we came upon trying, and response time was also good.
So when it was striking, I noticed the risk with making something really long is when it strikes, it will bounce.
Can you repeat?
So the arms are very long.
Yeah.
So when it strikes and it bounces, the frequency at which it bounces will be slower compared to
We have
if it
used
was
the
short.
spring for bouncing it back into the initial position. So the spring is of like 0.2.
No, I'm not talking about the intentional bouncing. I'm saying as soon as it impacts, there will be some rebound, right?
Yeah.
Now, if the arm length was short, it will bounce very fast, and you can reject that very easily, right? So, did you do anything in software or hardware to correct for this bouncing?
No, we tried on a hardware model only. For the spacing which is needed, we reduced the arm length and tried. And we have given the gaps as 10 centimeter gaps also. So keeping the safer side, we took 10 plus 5, 15 centimeter gap as it will strike in between.
No, my question was when you want to make contact, as soon as it makes contact, it will bounce off, and you are using solenoid as the sensor, right? So
sensor that we are using, MPR121 sensor, it has an inbuilt debouncing circuitry. So if it bounces, the MPR121 takes care of that.
So you said you have done a lot of research on that classification, right? None of the teams got 60 out of 60. Is it possible, do you think? Not possible. So none of the algorithms help you find
the best.
Depends on the data set and number of features which we use for classification and training the model. So the better features we select for classification, and the large number of data sets which we use depends on the classifier as well. The efficiency and accuracy will differ. Okay. So provided this limited number of time, we tried our best with different data sets and models. So this was the maximum which we got till yesterday night.
Okay. All the best.
Thank you, sir.
You are Nikhil Bhat.